Today's problem from Fourier Series. Okay, and the problem is prove that in 0 less x less c, x is given by the series, the Fourier series is given here. Okay, from the given range, it is clear that this is the half range series. Okay, and also from the given series, we say that this is half range cosine series. Okay, so we let first the half range cosine series in 0 less x less c of x is, what is the cosine series? The cosine series is a0 by 2 plus summation n equal to 1 to infinity a n cos n pi x by c. Okay, this is the half range cosine series, right? Here a0 this is equal to 2 by c into integration 0 to c fx dx. What is fx? Here fx is x. Okay, it is given, so we put here 2 by c into integration 0 to c x dx, that is c square by 2 into 2 by c, so we get c. That is the value of a0 is c. Now an, what is an? An is 2 by c integration 0 to c fx cos n pi x by c dx, and by putting the value of fx, which is x, here we put the value of fx, this is x, we put here, and integrate this by integration by parts. Okay, and getting that 2 by c into the first term is x is fixed, and the integration of cos n pi x by 2 is x into sin n pi x by c by pi n pi by c. This is the first term, minus integration, the derivative of x, this is the first term, is 1, and integration of this is sin n pi x by c by n pi by c dx. Now integrating again this term with respect to x, we get this is cos, and the integration of sine is minus cos, so this is plus, and we get here another n pi by c in the lower, and integration is omitted from this, dx is omitted, and the range is 0 to c. Now by putting the upper limit and lower limit of the integration, we get, if we put c here, then we get sin n pi, this is 0, and put when 0, then x equal to 0. So the contribution of the first term is 0. Okay, and from the second term, obviously we get 2 by c here into c square by n square pi square for this term, and by putting the value of c and 0 here, we get cos n pi minus cos 0. So we get 2c by n square pi square into minus 1 to the power n minus 1. Okay, this is the an. Now putting the value of a0 and an, we get the Fourier series as Fourier series of x as x, this is equal to a0 by 2, that is c by 2 plus summation n equal to 1 to infinity, we put the value of an, this is 2c by n square pi square into minus 1 to the power n minus 1 into cos n pi x by c. Okay. Now when we expand the series, then when we put the odd term n equal to odd number, that is 1, 3, 5, then this is negative and this is also negative. So this is minus 2 here, and when we put even term, then this is positive, so 1 minus 1 is 0. So for the even n, for even n, terms are 0. Okay, and we get only the odd term, that is for odd value of n, and we get as c by 2. We take common minus, so this is minus, and putting the value of, so we take common 4c by pi square. Okay, and by putting the value of n, this is equal to 1 first, then we get this is cos pi x by c into 1 by 1 square. So we cannot write any term here. Okay, and the second term is when we put n equal to 3, then we get cos 3 pi x by c into 1 by 3 square. Okay, because here n square present, and when we get n equal to 5, then we get 5 square into cos 5 pi x by c and so on. Okay, and clearly this relation gives the Fourier series of x, and we want to prove this series which is given in our problem. Okay, so we prove the Fourier series of x. This is half range cosine series. Now to deduct these two results, result 1 and result 2, we use here Parseval theorem of Fourier series. Now we see first what is Parseval theorem of Fourier series. Now to deduce the first deduction, that is 1 by 1 to the power 4 plus 1 by 3 to the power 4 plus 1 by 5 to the power 4 to infinity, this is equal to pi square by 96. We use here the Parseval theorem. And what is Parseval theorem? We already write here the Parseval theorem. Parseval theorem in the full range minus pi to pi is given by integration minus pi to pi fx whole square dx. This is equal to pi into a0 square by 2 plus summation n equal to 1 to infinity n square plus dn square. Okay. In half range series, for cosine series, this is pi by 2 into a0 square by 2 plus summation n equal to 1 to infinity n square only. And for sine series, there be no a0, no n, there be only bn term. Okay, this is the Parseval theorem. So our series is half range cosine series. So we use the formula is given by integration 0 to c. This is x whole square dx, because fx equal to x, and the right side is c by 2. Here pi by 2, we put c by 2, and a0 square by 2, this means c square by 2, we already find the value of a0, plus summation n equal to 1 to infinity, this square means 4c square by pi to the power 4 into minus 1 to the power n minus 1 whole square by n to the power 4. Okay, squaring this term, we get this result. Now when we take n is even, then this is 0, and if we take n is odd, then this term is 2, so from here we get 4. Okay, so we write the series as c by 2 into c square by 2 plus, this is 4c square by pi square into 4 by 1 to the power 4 plus 4 by 3 to the power 4 plus 4 by 5 to the power 4 and so on, right? And the left side is, this is cq by 3. Now calculating, we get cq by 3 minus cq by 4. This is equal to 4 cq by 2 pi square into, we take common another 4, so this is 16, and this is 1 by 1 by 1 to the power 4 plus 1 by 3 to the power 4 and so on. Okay, and it is clear that this is our given series, so we have to find the value of this series, and this is given by 12 cq and this is 16 cq by 2 pi square into 1 by 1 to the power 4, 3 to the power 4 and so on, and getting the result as, this is, we get pi square by, this is 96 is equal to 1 by 1 to the power 4, 1 by 3 to the power 4, 1 by 5 to the power 4 and so on. And clearly this is our first deduction, right? This is our first deduction, and we get the second deduction very easily using the first deduction. We write first the left side, this is 1 by 1 to the power 4, 1 by 2 to the power 4, 1 by 3 to the power 4, 1 by 4 to the power 4 and so on infinity. Let it be s. Clear? We have to prove s, this is equal to pi to the power 4 by 90. Now we first write the odd term only, 1 by 1 to the power 4, 1 by 3 to the power 4 and so on. Then we write the even term, this is 1 by 2 to the power 4, 1 by 4 to the power 4 and so on. And clearly from the first deduction, this series is given by pi square by 96. Clear? And now we taking common here is 2 to the power 4, right? And we get 1 by 1 to the power 4, 1 by 2 to the power 4, 1 by 3 to the power 4 and so on. Okay, so we put here pi square by 96 plus 1 by 16 into s, because this series is given at first. Okay, now we changing the sign of s by 16 and getting the value s minus s by 16, this is equal to pi square by 96. So 15s by 16, this is equal to pi square by 96, and this gives s, this is equal to pi square by 96 into 16 by 15, and clearly this is pi square by 90. Okay, so our value of the second series, that is the value of s, this is equal to pi square by 90, and this is the second deduction, right? Thank you, Patra.